Hi, everyone. Here are the last couple of examples from the notes in class that we started together on Friday. We talked about slope fields and we kind of talked about how to create a slope field, and then we talked about particular equations. So I'm just going to go over a couple of more examples of these with you. Start with example 5. So this is originally the ones that I skipped over in class. In this case, we're given the differential equation dy dx is equal to x plus 1 over y. I actually went and created a table of values for all the points that I was given in my slope field. And I was able to calculate the slopes by, again, just substituting these x values and these y values back up into my differential equation to get my dy dx. And remember that the dy dx is representing the slope at that point. So at the point -1, -2, my slope would be 0. And that's going to be the same for any of my x values of -1. They're all going to have slopes of 0. And then I started next with my x values of 0. So at the point 0, -2, my slope would be -1/2. So it's just going to be negative slope, not too steep. Then at the point 0, -1, I'm going to have a -1 slope, something like that. But at the point 0, 0, I'm actually going to have a slope that's going to be undefined here because, and actually it would be undefined here as well, because with the y value being 0, remember that we can't ever divide by 0, so that would mean that the slope at the y value of 0 would actually be undefined. So I should have actually put that little slope line in there. So I'll continue with the point 0, 1, my slope is going to be 1. And then the point 0, 2, my slope is going to be 1/2. And then I continue on with my x values of 1. So at 1, -2, my slope is going to be -1. Then at the point 1, -1, my slope is going to be -2. Again, at the point 0 or 1, 0, I'm going to have an undefined slope because my y value would be 0 in the denominator there. 1, 1, my slope would be 2. And then at the point 1, 2, my slope is going to be 1. So here's my slope field for these 12 points here. So then now that I've got my slope field, part B is asking me, while the slope field is actually only drawn at these 12 points, it is defined at every point in the plane. So for example, if I were to kind of extend this plane to the left and to the right and up and down, obviously my slope field is going to continue. It's asking me to describe all of the points in any coordinate plane that I could draw here that my dy dx is going to be equal to -1. So since we know what dy dx is, I can actually substitute in this value of -1 up here for my dy dx, and I can actually solve for the equation that's going to give me all points in this plane for which my slope is going to be -1. So I know my dy dx is x plus 1 over y, but I know that my slope is -1. And if I multiply each side of this equation by y to clear my fraction, that's going to give me -y is equal to x plus 1. So that's going to tell me that for any value or any slope that is -1, all of my points would be on this particular line. So I'm going to say dy dx is equal to -1, or my slope is -1 for all points in my coordinate plane when y is equal to -x minus 1, but I also have to put the stipulation in there that I can't have any y values of 0, again, because that is going to be the undefined part of my coordinate plane. So my slope is -1 for all points in my coordinate plane with the equation of the line y is equal to -x minus 1, but y can't also be equal to 0. So then the particular solution was kind of what we talked about at the beginning of class on Friday. We wanted to find the particular solution to this function for the differential equation with the initial condition f of 0 is equal to -2. So I'm going back to my dy dx is equal to x plus 1 over y. I want to separate out my variable, so I want to get all of my x's on one side of the equation, all of my y's on the other. So I'll just cross multiply here. So that's going to give me y dy is going to be equal to the quantity of x plus 1 dx. And remember that I want to solve for y here, so I'm going to go ahead and integrate both sides. My integral of y dy is going to be 1/2 y squared. And my integral of x plus 1 is going to be 1/2 x squared plus x. And I'm going to put my plus c in here. And before I actually use my initial condition here, you could plug it in at this point, but I'm just going to kind of go ahead and try to get y by itself as much as I can first. So I'm just going to actually clear out this fraction by multiplying each side of the equation by 2. So 2 times 1/2 x squared plus x plus c. That's going to tell me that y squared is going to be equal to just x squared plus 2x plus c. And now I'm going to go ahead and use my initial condition to solve for this c value. Again, you could have done it in this step if you wanted to. I like just simplified things just a little bit here first. So -2 squared plus, if I put in zeros here, that's just going to leave me with, that's going to be an equals. That's really just going to leave me with a c. So that's telling me that my c value is actually +4. So then I can go ahead and I'm just going to actually go back to the step over here, and I'm going to say y squared is going to be equal to x squared plus 2x plus 4. And that's going to tell me that when I solve for y here, my y is going to be equal to plus or minus the square root of x squared plus 2x plus 4. But remember that the equation that we choose to use with the plus or minus has to fit our initial condition. So this is telling me that I have two possibilities here for the y. It could be y is equal to the positive root of x squared plus 2x plus 4, or it could be y is equal to the negative square root of x squared plus 2x plus 4. But I have to think about what's going to make that true. What happens if I actually substituted in the 0 over here? Well, if I put in a 0, that would give me 0 squared plus 2 times 0 is 0 plus 4 underneath the root. And if I take a square root of that, that's going to give me a +2. But my initial condition says I need to get a -2. So this part is not going to work. I don't want to take the positive root. Over here, if I substitute in a 0, that's going to give me the negative root of 0 plus 0 plus 4. That's going to give me the square root of 2 underneath, but the negative is going to give me that -2 that I initially wanted for my initial condition. So my particular solution here is actually going to be y is equal to negative square root of x squared plus 2x plus 4. Okay, so then I want to go back to example 6. I know we already did the slope field in part B of this one. We didn't make it all the way through part C, so I'm actually just going to walk through this one kind of fully again, just to kind of explain things and kind of get the flow of the problem again. So in this case, we were talking about the function or the differential equation dy dx is equal to xy over 2. And I'm going to do pretty much the same thing I did in the last problem. I'm going to actually cross multiply to solve here, or to clear my fraction anyway. So that's going to give me 2 dy is equal to xy dx. I want to get rid of this y because I want to get all of the x's by itself over here on this side. So in order to do that, I can go ahead and divide each side by y. So that's really going to give me 2 over y dy is going to be equal to x dx. And now that I've got my variables separated, go ahead and take the integral to get the antiderivative. And I said in class that this 2 over y is really the same thing as taking a 2 out as a constant, because that's really the same thing as multiplying 2 times 1 over y. And the reason that we want to do that is because over here on the left-hand side, when we're left with a 1 over y and an integral, that's going to kind of clue us in that we would need to use some sort of natural log here. So I'm going to go ahead and do that integral. That's going to be 2 times the natural log of the absolute value of y. And on the other side is going to be equal to 1/2 x squared plus c. And at this point, we said that we can, if you wanted to go ahead and get rid of the 2, you could. Like I did in the last problem, I did get rid of that constant that was in front, but it's really up to you if you want what you want to do. I think in class, we actually went straight to our initial condition to use the f of 1 is equal to 1. So I'm going to go ahead and do that. So it's going to be 2 times the natural log of the absolute value of 1 is going to be equal to 1/2 times 1 squared plus c. Over here, I'm going to get a 0 because the natural log of 1 is 0. So it's going to give me 0 is equal to 1/2 plus c. That's going to tell me that my c value is negative 1/2. So now that I know that, I can go ahead and say, okay, well, if I know this initial condition or I know that c value, I'm going to go ahead and do my work up here. This is going to give me 2 times the natural log of the absolute value of y is going to be equal to 1/2 x squared minus 1/2. And then we can go ahead and clear out this 2. So divide by 2 or multiply by 1/2 on either side. So it's going to be 1/2 times the quantity of 1/2 x squared minus 1/2. That's going to tell me this is the natural log of the absolute value of y is going to be equal to 1/4 x squared minus 1/4. And now we want to get the y by itself. So remember to undo a natural log, and I think this is kind of where we left off in class on Friday. Remember that you can exponentiate both sides of the equation. So that would mean, remember that this base here is really an e. I can rewrite this in exponential form to get rid of the natural log here. So remember that rewriting some sort of natural log or some sort of logarithmic equation, you want to take your base. This stuff over here on the right side is really your exponent, and that's going to be equal to the absolute value of y here. So writing this in exponential form, e to the 1/4 x squared plus 1/4 is going to be equal to the absolute value of y. But then what does this mean? What does the absolute value of y mean here? We want to get y equals not the absolute value of y. So that would mean that the absolute value of y could actually be either plus or minus this quantity. Because if I put a positive e to this exponent into an absolute value symbol, I'm going to get a positive e raised to this exponent. But if I put a negative e into the absolute value bars, well, the absolute value of negative e raised to the 1/4 x squared plus 1/4 is still going to be positive e raised to this exponent. So this is really telling us that y could either be plus or minus e to the 1/4 x squared plus 1/4. Again, because if I were to take either one of these expressions and put it into the absolute value, it would still produce a positive e here. But again, how do we choose which one this is? Well, that's going to bring us back to our initial condition. We want to make sure that when we substitute in an x value of 1 and we evaluate, we're going to get a positive 1. So this is telling us we could either have y is equal to positive e to this exponent, or we could have negative e raised to this exponent. But again, if I put in a positive 1 for my x value and I were to evaluate here, this is going to give me e. If I put in a 1 here, this is going to give me 1/4 plus 1/4. Oh, how did that become a plus? That should be a minus. Sorry, that should be a minus. I was wondering why that wasn't working. Yeah, because over here, if I do e to the 1/4 minus 1/4, that's really e to the 0, which is going to give us a 1. And then if I were to plug in or substitute in a 0 here, this is going to be negative e to the 1/4 minus 1/4, which is really going to be negative e to the 0, which is going to be negative 1. So in this case, this one does not fit our initial condition because our initial condition needs to say that f of 1 is equal to 1. So this one does not work. So that would tell us that our y should be the positive e value. So my particular solution is y is equal to e to the 1/4 x squared plus 1/4. But the other part of our question is also asking us to use the solution to find f of 1.2, which we did up in part B with the tangent line. But now that we know what our particular solution is, we want to know, okay, well, what happens if I take a 1.2 and I substitute it in up here in my exponent? So here's the second part of the question. What is f of 1.2? Well, that's going to be e to the 1/4 times 1.2 squared plus 1/4. I'll get out my calculator here to evaluate. So that should be minus. I don't know why I keep on writing plus. So if I evaluate, I just put that in my exponent, or that stuff that's in my exponent in my calculator. That's e to the 0.11. And that's about 1.116, which I believe in part B, we said that it was about 1.1. So it seems to be around the same value here. So we're going to say that f of 1.2 is equal to about 1.116. All right, so those are examples 5 and 6. Hopefully these will help you to complete your homework. Let me know if you have any questions.